Hello everyone. Today we are going to see about the topic first order transition in solid state physics. Introduction. First order transitions are the fundamental phase changes in solid state physics where a discontinuous changes occurs in the properties like entropy, volume or enthalpy. These transitions are marked by the absorption or release of the latent heat and involve a finite temperature range. Common examples include the melting point, boiling point, and the solid state transformations such as ferroelectric to paraelectric shift. So the characterization of the first order transition is given by sudden jump in the entropy and volume, involvement of the latent heat during the phase change, coexistence of initial and final phases at transition temperature, hysteresis due to the dependence on the thermal path, and they are typically observed using the techniques like differential scanning calorimetry, thermal gravimetric analysis, and X-ray diffraction. So the thermodynamic framework, the Gibbs free energy remains continuous across the transition, but its first derivatives are not. The Clapeyron reaction is given by dP by dt is equal to del S divided by del V. Here del S is a entropy change, del V is a volume change. This reaction explains the slope of the phase boundaries in the pressure temperature diagrams and is central to predicting the material behavior under the varying conditions. The graph represents the first order phase transitions. The examples of first order transitions are melting of ice, solid to liquid, boiling of water is liquid to gas, graphite transforming into diamond is solid to solid, BaTiO3 undergoing the ferroelectric to paraelectric change, martensitic phase transition in shape memory alloys. Each example demonstrates the abstract nature of the first order transition and its significant effect on the material properties. Applications of the first order transitions are it used in the memory alloys, in medical stents and robotics. Phase change memory is used using in the GESBTE for data storage. Color changing materials in smart windows and sensors. And it also used in the high efficiency thermal batteries and energy storage devices. Magnetic refrigeration systems used magnetocaloric materials. These applications rely on sudden structural or electronic changes for functionality. Advantages: precise switching between phases for controllable behavior, and it used in high energy storage through latent heat, customizable material properties via doping or pressure. Non-volatile and reversible switching in the electronic devices. Enable design of responsive and adaptive smart materials. Disadvantages is disadvantage in hysteresis causes inefficiency in the cyclic applications, mechanical fatigue due to repeated phase changes, impurity sensitivity affects reproducibility and stability. Transition temperature spread may reduce the applications range and requirement for the specialized equipment for phase control. Conclusion: the first order transitions are the pivotal in modern material science, offering sharp phase boundaries and valuable functional changes. Their thermodynamic and structural properties make them suitable for advanced devices in memory, sensing, and energy sectors. Addressing limitations like hysteresis and material degradations remains crucible for the future advancements. Thank you.